Alright, so -3 square root of 5 plus 2 square root of 45 plus 2 square root of 5. Okay, so, oh, we didn't do the notes either, did we? Did we fill in any of these notes? We just did the top. Okay, perfect. To add or subtract, the radicals must be identical. To add and subtract, the radicals must be identical. Teacher's note, and this is very important, it is okay to have multiple radicals in your answer, which you'll see when we do problem number 2. Alright? To add or subtract, the radicals must be identical. It's like variables. We can multiply anything we want, but to add and subtract, they must be like terms. So when I go on the back, alright, -3 root 5 plus 2 root 45 plus 2 root 5. Alright, so I'm looking at these two. Why? Because those two radicals are exactly the same, so I can put them together. -3 plus 2, same thing as 2 minus 3. What type of 1 do I get? -1. Your choice if you want to write the 1 or not. So I got -1 root 5. Okay? For the time being, I'm just going to rewrite the 2 root 45. Alright, now, is there a perfect square from yesterday that goes into 45? Which one does? 9. So the square root of 45 is the square root of 9 times 5. Why 9? Because 9 is a perfect square. What is the square root of 9? 3. So this becomes -1 square root of 5 plus 2 times 3 square root of 5. What is 2 times 3? 6. So this is -1 root 5 plus 6 root 5. -1 plus 6 gives me a positive what? 5, and I got 5 root 5. Alright? Well, look at that. 2 root 45 there, 2 root 45 there. Do they have to simplify to the same thing? Absolutely. So 2 root 45 is 6 square root of 5. Okay. So that's from the previous problem. Now, 3 root 18. Is there a perfect square that goes into 18? 9. What's the square root of 9? 3. I'm going to multiply by the outside number, which is also 3. And that's going to give me 9 root 2. Notice their radicals are different when they're simplified. That means we're not going to get one final radical in our answer. We're going to get at least 2, depending upon what happens with the last one. Is there a perfect square that goes with crazy 8? 4. What is the square root of 4? 2. I multiplied by the outside 2. That would give me plus 4 root 2. Now, do I have radicals that are the same? Yes, so I can put those together. What's 9 plus 4? So I got 13 root 2. I still got a 6 root 5 out there. Boom, and I'm done. I don't have to do anything else with it unless it asks me to estimate. And if it doesn't tell you to estimate, you assume it's exact. So therefore, that would be your final answer. So no one should come up on a quiz that we eventually take on this and say, is it this or this? It's that. There's no ors. Ors are for rowing, not math class. Unless you have a quadratic, and then I guess you could have ors. Okay? Multiplying. We can multiply and divide any radicals we'd like. We can multiply and divide any radicals we want. So those do not have to be like radicals for us to do it. So those do not need to be like radicals for us to do it. Alright, so if I'm looking at number 7, this is an example of what we call the distributive law. When we multiply everything on the outside by everything on the inside. So the square root of 3 times 3 is 3 root 3. The square root of 3 times the square root of 5, 3 times 5 is 15. So again, when you're multiplying radicals, you're just multiplying the values together. Alright? Please take a moment to work on number 8. Please take a moment to work on number 8. Everybody okay with that? Square root of 150 plus square root of 45? Everybody good with that? All right. Everybody good with that? 5 root 6. Everybody good with that? 3 root 5. Because 9 goes into 45. Square root of 9 is 3. 45 divided by 9 is 5. Notice, inside parentheses, how many terms did you have? 2. How many terms did we end up with at the end? 2. Chances are that's going to happen. So when you start doing multiplication, it's not really going to get rid of things. Now, when we divide, we've got to talk about what's called rationalizing denominators. After simplifying the denominator, multiply the numerator, numerator, and denominator by the simplified radical, which is equivalent to multiplying by 1, and our number maintains its value. Simplify both or either accordingly. Okay? So, if I look at number 9, a little hint, I'm going to rewrite it as 1 over 2 times the square root of 2 over the square root of 8. So in other words, I'm going to separate it. Everybody good with where the 1 came from? Since there's no number in front, we're assuming we're multiplying it by 1. The reason I do that is this. This becomes 1/2 times the square root of 1 over the square root of 4. In other words, just like multiplication, I can divide anything I want. And dividing fractions is the same thing as reducing. So all I'm doing is reducing the fractions. Why is that nice? Because 1 and 4 are both what? Perfect squares. And I don't need to rationalize. So this becomes 1/2 times 1/2, which is 1/4. Alright? Square root of 1 is 1. Square root of 4 is 2. Square root of 1 over square root of 4 becomes 1/2. 1/2 times 1/2 is 1/4. Now, if I look at number 10, I don't have any outside numbers, so I don't need to break it down. But does 12 over 15 reduce as a fraction? Yeah, 3 goes into both, so that becomes what? Square root of 4 over square root of 5. Now, what is the square root of 4? 2, so this becomes 2 over the square root of 5. But we are not allowed to have square roots in the denominator. So that is why we multiply top and bottom by that denominator. This is what we mean by simplify first. It makes our numbers smaller and easier to manage. You don't have to do it that way, but if you don't, you're going to have to simplify your radicals at the end. 2 root 5 times root 5 is just that, 2 root 5. Now mathematically what is happening is this becomes the square root of 25, and the square root of 25 is 5. What you can remember is what is squaring a square root do to itself. When we square a square root, what do the operations do to each other? Cancel out. That is the purpose. Alright, try 11, please. Try 11. If you ever want to check it, here's what you do. You put in your calculator. So to do square root, we hit second, and then squared by. Now you put in 1/4. That's okay. You can always check it. Seriously, I have no problem. I want you guys to be effective with the calculator as a tool. So we're going to spend a lot of time working on this. So there's nothing wrong, there's nothing cheating. Yes, sir. What are you using it for? It doesn't like to be used. Things don't like to be used. It makes them... Yes, go, go, go.
What was the teacher's note?
What's that?
When you're
I'm going to put it when we're done.
I want to go through this one.
Go. There we go. And there we go. All right. Oh, what's a flying fish? You had all the answers. Too honest. All right. So I'm going to multiply top and bottom by root 2 over root 2. Everybody good with that? This becomes 5 root 2 up top, and that becomes 4 in the denominator. All right. If you ever want to check your work, the original problem, you just got to be careful. The original problem is 5 divided by parentheses 2 square root of 2. And it gives me that decimal, 1.76. And then I look at my final answer, which is 5 seconds square root of 2 divided by 4. Are the two decimals exactly the same? Boom, shakalaka, you know you've done good. Good? All right, so for those of you that want to know the teacher's note, when you are not asked to estimate, leave all radical answers in simplified form. So the only time you estimate is when it tells you to leave it in simple form. Why? Because guess what? We're going to start now a little thing called Pythagorean theorems. All right? That's what this is all about. Pythagorean theorem. True or false? Pythagorean theorem is not on Friday's test. True. Okay? 3.5 is the last thing. Simplified radicals isn't on there either. In a moment, you'll get a test review packet. It's up to you to do it or not. It's your choice. But you'll know everything that's on it. What with the simplified radicals in this is not on your test. There's no Pythagorean theorem. I know some of you are sad about that because you love Pythagorean theorem, as you should. Pythagorean theorem is what you're going to use the most in life. Trust me. All right? Hoping that by the end of the week, I better stop recording. Hold on.